Hey everybody, welcome to part 2 of the video. I'm your new teacher now.
Hey, what are you doing over here? Get out of the way.
Trying to do my math homework.
Get out of here. This is my video.
I don't want ice cream.
All right. Interruptions. Okay, so here we go. Our first question we're doing here is about dilating a point or a figure where the center is not the origin. We know if the center is the origin, you just multiply and you're good to go. Here you're going to do some counting. So we already have a triangle drawn. Gotta love the pencil here, right? It's at the points -5, -4, -1, -5, -2, -2, and the center of dilation is actually -5, -5. It's right here. This is the center. So all we really need to do is figure out how to get from the center to our point, and then just do that however many times you need to based on the scale factor, right? So if it's 3, if I have to go up 1 to get to F, I'm actually going to go up 3, right? Multiply that times 3. So it's up 1, okay? 1 more, and then boom, that's 3, okay? So this is a dilation of 1. Do it again for dilation of 2. Do it again for the dilation of 3, okay? So if our center of dilation is -5, -5, it's going up 1, so it's left and right 0, and then up 1, right? We're going to multiply those amounts by 3. Does that make sense so far? So it's the point -5, -5, and then we're adding 0 and 3, and we get -5, 2. So what we've done, right, is we've counted, this is the dilation of 1 to get back to the figure. This is 2, 3. And so if you look, this is the point -5, and this should be -2. And that's it. Okay, that's the new prime, and that's F prime. Okay, so G is to the right 1, 2, 3, 4. Now that's a dilation of 1, so we got to do 4 more. 1, 2, 3, 4. That's a dilation of 2. 1, 2, 3, 4. That's a dilation of 3. And that's where G prime is going to go. So we know from the center to G, okay, is 1, 2, 3, 4. So it's 4, 0, right? We multiply that times 3, so that's 12, 0. And we take -5, -5, and we add it on. And so this is going to be -5, this is going to be 7, and so G prime is going to point 7, -5. So 1, 2, 3, 4, 5, 6, 7. There we are. Okay? So H is to the right 1, 2, 3, and up 1, 2, 3. So that's 1. We do it again. 1, 2, 3. 1, 2, 3. She's on the phone. Wait for her to get off and you can go to. So then we're going to go up again. 1, 2, 3. 1, 2, 3. Boom. 3, 3. And there's my new point. There's H prime. Someone else would like to say hi.
Me.
Say hi, Kate.
Hi.
So we have F prime, H prime, and G prime. It's a triangle. We're just going to draw, and you should be using a straight edge. Don't do the freelance work like this, right? Okay. And there is our triangle. Don't draw on stuff like that, okay? And that's it. So this was 3, 3, right? We're going to multiply by 3. It's going to become 9, 9. And then we're going to add -5, -5. That's our center onto that. And we get 4, 4. Okay, that's it. And you can see 4, 4. Don't give me. No, you can't. I know, but you're scraping stuff. You can't do that. Okay, given the preimage, determine the following equations after each transformation. So we're going to take this line, y equals -x plus 3. And we're going to do a dilation about the origin with the scale factor of 2. Now remember, the first thing we want to do for this this question here is check is the center on the line. If it is, right, then the line doesn't move. Stop doing that, please. Some of the kids. Second, if it's not on the line, okay, then we're just going to multiply the scale factor. We're going to count just like we did here. How far is it to get to the line? And we're going to double or triple that amount. Okay? All right. We want to dilate 2 points on the line, and we want to redraw it. Okay, so the first one is y equals negative x plus 3. So it's up 3. And then we have a slope of, well, down 1 over 1, right? Or up 1. Whoa, wrong way. Down 1, right 1. Not here. Or up 1, left 1. So this is what this is going to look like. Right, we're going to need a little ruler here, people. Let's get some, not some of that cake. I think that works right there. It's even hard to tell, but we'll go with it. All right. Not drawn very awesomely, but considering it's supposed to be like this, right? That's why sometimes it's nice to draw those points all the way up the line to see what you're graphing it correctly. Okay. Not that one. Okay. So it's a scale factor of 2. So if you look at here, here's the center. All we're going to do now is time out. Catherine Teresa, stop banging into stuff or I take it away. Okay, so we're going to go up 3. That's a dilation of 1. Okay, and then we're going to do dilation of 2. We're going to go up 3 more, and boom, there's my new, that's my new point. If we did another point, so let's say we chose this point, it's over 2 up 1. That's 1. I go over 2 up 1, and boom, there's my other point. Now, if we use the slope of negative 1, we just go down 1 over 1, down 1 over 1. And look at it, it's going to go right through that point regardless, okay? So the slope's going to stay the same, the lines are going to be parallel, and we're going to get that line right there. Okay. Determine the equation of the image after the dilation about 0, 3. So 0, 3 with a scale factor of 4. And remember, we need the equation here. So the equation and now is the same slope, so it's y equals negative x, but now the y-intercept is just increasing, so it's flex 6. This one is going through, the center is on the line. Remember, that doesn't change, so it's just y equals negative x plus 3. And determine equation about the image about 1, 1. So let's find 1, 1 first. So 1, 1 is right here. We want a scale factor of 3. So if you think about, we're going to dilate this point right here. We're just going to go 1. That's the dilation of 1. Here's 2. Actually, from the point, right? Center out. 1, 2, 3. That's my new point. Let's take this point right here. This is y-intercept. We're going to go over 1 and up 2. Over 1 up 2. That's 2. Over 1 up 2. And there's 3. And you can look. There's our line with a slope of negative 1. So our line looks just like that. Thank you for my hug. I'm talking to my daughter, guys. She's also waving at the computer instead of at the camera. Ready? You already did say hi. All right, and then we can see the slope. It's still the same thing. So it's y equals, get back up here, right? Negative x. Hold on. And then it's 1, 2, 3, 4, 5. So plus 5.
On the other side.
All right, special guest time. Oh my gosh. All right. You guys gotta get out of here. You gotta finish this. Get out of here.
No, Daddy.
All right. I will come and I will. All right. Okay. So last part is similarity transformations. So in a similarity transformation, okay, remember what we're doing is we're describing in words. So remember, dilation, we want to talk about what point are we dilating. So what are we dilating, around what point, and what's our scale factor. If you need to get the scale factor, you divide. If it increases size, it's large over small. If it's decreasing, it's small over large. Translation. Name the vector array. So what are you translating what, along what line, such that what maps onto what. Rotation is rotate what shape, about what point, and then how far, so that something maps onto something, or is it going 90, 180 degrees? For reflection, we're going to reflect what over what line, and then so that what maps onto what. Okay, so we got composition, remember, is doing one or more at the same time. If you see this, it means we work backwards. So we do the reflection first and then the rotation, okay? And we're usually using a sequence of rigid motions, which are congruents, okay? Or if it's similarity, it's going to be with a dilation involved. Okay, so let's take a look at the first one. Describe a sequence of similarity transformations that shows that XYZ is similar to UVZ, okay? So we're going to move this figure onto this one. Now, what we need to do is we need to do two things. Number one, we need to turn it, okay? And then we need to dilate it. So we're going to say, now you want to give like an order. So say first, we'll say first, rotate. Now what are we rotating? Triangle, X, Y, Z. No, not UK. Okay, what center? Around point Z, and then clockwise or counterclockwise. So we'll go clockwise. It does not matter which way. Okay, and then how far? So that, and then we're going to say, what we want to have happen is we want to stop, like when this line, right, goes on top of this one. So that YZ overlaps or maps onto, and then VZ. Okay? Then, so the second thing we want to do is we want to dilate. What are we dilating? Triangle XYZ. What's the center? Okay. We can say center. Not Miko. At Z. And when do we stop? Or how far? So by, and now we just need to use a proportion. So pick two corresponding sides, and we want to get bigger. So we want to do bigger over smaller. So we're going to say VZ over XZ. And you could have done XY over UV, any one of those. And that'll make it happen. Okay? So that's good. Okay. Next one is on a graph. So now we can use our rules of translations and rotations and reflections. And so what we want to do is we want to get this to map on to this. So there's a couple options, right? If you're looking at this, you're going to say, well, if I just rotate this ring and right and swing it around, okay, it almost looks like it'll work, but it's actually a reflection, right? I want to reflect this down this way, and then I want to reflect this over this way, right? If I rotate it 180 degrees, right, A is going to be pointing in this direction, and we want it to go this way. So there's a couple things we can do. We can translate it, so we just slide it over, and then we can reflect it, or we can reflect it down, so it's down here, and then reflect it across. So let's do the translation first, because we have done. It'll cover all our bases here. That's right. Thumbs up, Kate. Okay. So first. And the first thing we want to do is we want to figure out if I move this over, and I can draw this thing, so where I want it. This is 3 up and 3 more up. So this is exactly where I want A to go, okay? And then E is going to slide right over here. And then F should be, all right, get out of here, you. All right, it's up, it's basically up 3 and over 1. So it's going to be right here. So this is where I want to move this to. And then I can reflect it right over that line and get it across. And there's an inchworm on my paper. So first, we're going to say we want to translate, right? What are we translating? Triangle A, B, C. And now, since we're on a graph, we can just describe it, right? 4 units to the right. That's it. Or how many units to the right? 1, 2, 3, 4, 5, 6. So 6 units. Right. And that's it. That's all we're doing. Okay? So we tried, what are we translating? We give a direction, right? We said how far, and we're done. Okay? Then, now you also could have done as a translation. So this would be 6, 0. And that would have been okay too. All right? So then we want to reflect triangle ABC over. And now what line do we want to reflect over? We can either say y equals 0, because that's what this is, or over the x-axis, and then so that it maps onto triangle DEF. And that's enough. Okay? That's it for today, guys. If you need anything else, let me know. I won't be in tomorrow. Remember, you guys are working on the exam tomorrow. And then I'll see you guys on Monday. And everyone can say goodbye to Kate. Come here, Kate. I'll try this. All right, we're upside down, but it's just because now you can see Kate. All right, say bye, Kate. Later, guys.